how an elements or an objects can be arranged when two events are occurring simultaneously. The second event is occurring in n different ways, then the total number of ways can be written as m into n. I need to frame a code of 4 letters. So if one has taken, suppose I have all the chances, all 10 letters can be taken as the first code, then I cannot repeat the same. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So welcome to the session 1 of the new chapter, Permutation and Combination. So in this session, we will be studying about the fundamental principle of counting. So what do you mean by permutations and combination, and what do you mean by fundamental principle of counting? Permutations and combination is nothing but the arrangement of an object, whereas permutation is arranging the objects with certain order. Combination is nothing but the selection of object. There, the order is not necessary. But before going to permutation and combination, we will study what do you mean by this fundamental principle of counting. So here we are going to learn the fundamental principle of counting for any 2 or 3 events occurring at a time. So what happens or how an elements or an objects can be arranged when 2 events are occurring simultaneously? Let's look at it now. So fundamental principle for 2 events state that if the one event can occur in m different ways and another event can occur in n different ways, then the total number of occurrence of the event in a given order, this is very necessary, in a given order is m into n or m cross n. So if 2 events are occurring, one event is occurring m times and the second event is occurring in n different ways, then the total number of ways can be written as m into n. So this is the fundamental principle of counting. The same thing can be applied for the 3 events. So the fundamental principle of counting for 3 events states that if an event can occur in m different ways, the other event can occur in n different ways, and one more event can occur in p different ways and in a given order, then the total number of occurrence will be m into n into p. For example, when you toss a coin 2 times, what is the occurrence of a results? That is, the chances of occurrence of head or tail will be 2. So, and the second time is also 2. So it is m into n. Again, if you go on third time, it is 2 again. So there the total number of arrangements will be 8. Suppose you have taken only 2 trials, the total number of arrangements will be 4. So like this, the number of arrangements can be recorded for a n number of events occurring in different ways. This is nothing but your fundamental principle of counting. So in aware of this, we come across different types of arrangements of numbers, alphabets, or any signals. Let's look at those problems now. The very first question is, how many 3 digits number can be formed from the digits 1, 2, 3, 4 and 5? So we have 5 numbers here. Assuming repetition of the digit is allowed, repetition of the digit is not allowed. Usually in an arrangement we come across 2 types. One is the repetition, another one is without repetition. What do you mean by this repetition? Now here we have a numbers 1, 2, 3, 4, 5. We are supposed to frame 3-digit number. 3-digit numbers, units place, tens place, hundreds place. Consider this. Now we are supposed to form. How many numbers we can form? That we don't know before going to the condition. We may have 2 conditions. One is repetition of the digits. We arrive numbers of the form 441, 112, 133, so 355, like this. So here you can see the digits are repeated in units place or tens place or hundred place. So this is nothing but with repetition of digits. Without repetition of digits mean we are supposed to calculate the digits which are not repeating. For example, 1, 2, 3, 4, 5, 3, 3, 4, 2, like this. So you can see the digits are not repeating here. So now let's look at the repetition of digits is allowed. We have 5 numbers here. So for the first case, I have 3-digit number, units place, tens place, 100 place. Let's start filling from the hundreds place or unit place. In either way you can fill it. If I fill all the 5 numbers in the hundreds place. So since repetition of digits is allowed there, again all the 5 numbers can also be filled in the tens place. Again it is possible in the units place also. So therefore total ways here is 5 into 5 into 5, which is 625. So we can form 625 numbers or 3-digit number. 625 3-digits number are possible with repetition of digits. Now let us look at the second condition. They have said without repetition. So let's consider units place, tens place, 100 place. Suppose I'll take any number out of 5. So I have 5 chances of filling the 100 place. So let me take now among 1, 2, 3, 4, 5, I have already filled 1. Let us assume that 1 has taken the hundreds place. Now since the digits is repetition is not allowed, I cannot fill 1 again in the tens place. So the possibility of putting the digits in tens place is only 4 now. So I can write only 4. Now assume that 2 has placed in the tens place. 1 has taken 100, 2 has taken the tens place. Now the possibility that you can't repeat the digit, so only possible numbers you can substitute in unit place is 3, 4, 5. So that is you have only 3 chances. So therefore 3. So therefore here total ways becomes 5 into 4 into 3. That is 60. So only 63 digits numbers can be formed without repetition of digits. So therefore the arrangement, as I said, come across 2 types. One is repetition of digits, the other is without repetition of digit. In the repetition of digits you have all the chances of substituting each and every place, but in without repetition of digit, once the place is fixed for one object, then it can't be applied for the other. So you have to reduce the number of chances each time and go on multiplying. So this is what the multiplication principle, that is fundamental principle of counting, says. Now let's look at the second question. How many 3-digit even numbers can be formed from the digits 1, 2, 3, 4, 5, 6 if the digits can be repeated? So here we can repeat the digits, but my aim is to form 3-digit even numbers. Okay, so here let me form 3 digits even number, units, tens, 100. If I have to form the even numbers, the units place must end with only the even numbers. That is, the units place can take only 2, 4, 6. If you put 1, 3, 5 in the units place, it will become an odd number. So the only chances that unit place can take is 3 numbers out of 6 number. Now the digits can be repeated. So I can put all the 6 digits in the tens place also. I can put all the 6 digits in the hundreds place also. So here the total number of ways will be 6 into 6 into 3. So total ways are 6 into 6 into 3. So that is equal to 108. So 108 3-digit even numbers can be formed from the digits 1, 2, 3, 4, 5, 6. Next question. How many 4-letter code can be formed using the first 10 letters of English alphabet if no letter can be repeated? So what are the letters we have? A, B, C, D, E, F, G, H, I, J. So these are the first 10 letters of English alphabets. Now I need to frame 4-letter codes. So they are asked no letter can be repeated. I need to frame a code of 4 letters. So if one has taken, suppose I have all the chances, all 10 letters can be taken as the first code, then I cannot repeat the same. Because if I take A in the first place, I cannot repeat A again. They have clearly said no letter can be repeated. So I have only 9 chances for the second place. Suppose I have taken some letter I now. Let me take A is one code, I is another code. A is already taken, I is also already taken. Now I have only 8 chances. Similarly, I have only 7 chances for the last one. So therefore, how many 4-letter codes can be formed here? So the total ways will be 10 into 8 into 9 into 7. That is actually 5040. So I can form 5044 code using first 10 letters of alphabets. Next question. A coin is tossed 3 times and outcomes are recorded. How many possible outcomes are there? If I toss a coin in the first outcome, I have 2 chances. That is, I can get either head or tail. So I have 2 chances in the first trial. Again, second trial also I have 2 chances. Again, in the third trials also I have 2 chances. So therefore, the total ways, or using fundamental principle of counting, I can write this as 8. So I have 8 possible outcomes when I toss a coins 3 times. Next question. Given 4 flags of different colors, how many different signals can be generated if a signal requires the use of 2 flags, one below the other? So remember the word here, different signals. Different signals means I have 4 flags of different colors. So they are all different in colors. I have to take only 2 flags. So this is flag 1 and flag 2. If I take any one of the color as a flag 1, the second will be other different colors only. So I have only for the first flag, I have 4 chances. That is, out of 4 flags of different colors, I can take any flag. But once flag 1 is taken, I have only 3 flags left which are in different colors. So therefore, the possibility is 3. So therefore, total ways here I can create different signals is only 12. So 12 different signals I can generate using 2 flags out of 4 flags. So the next question is, how many 2-digit even numbers can be formed from the digits 1, 2, 3, 4, 5 if the digits can be repeated? So here I can repeat the digit. So as I said, 2-digit even numbers means I have only units place and tens place. Units place have the chance of taking only 2 and 4. That is 2 chances. And here digits can be repeated. So I have all the chances of substituting for the tens place. So that is 5. So therefore, total ways will be 5 into 2, that is equal to 10 ways, or 10 2-digit numbers can be formed with repetition of digits. So this is how an arrangements can be done in different ways. We'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.